Okay, so so I have told you that current is a rate of flow of charge. Charge can be positive, charge can be negative. But in case of conductors, mostly there are free electrons. So electron is a negative charge. So means there is mostly the flow of negative charge. But I have told you that the direction of current is the motion of positive charge in the direction of motion of positive charge. Okay, we will discuss this all the things. And one thing more, like that I have said to you about the current, it's a scalar. But you know, vectors, the definition of vector is like
Having direction and magnitude.
having magnitude and direction.
Direction.
Okay, but one more thing, please add one more thing. For a quantity to be a vector, the quantity must follow the vector laws of addition. Means the quantity follow the laws of vector addition. Like for the current, if I am talking, like force is a vector. This is a 4 Newton of force in this direction, and this is a 3 Newton of force in this direction. And the angle between these two forces is just 90 degrees. And okay, now what is the resultant? The resultant will be something 5. Here is the resultant. When you calculate the resultant, you will get 5 Newton from plus 4 square. And suppose here is a current of 2 ampere. Here is a current of 3 ampere. Can I write the resultant? In this case, I cannot write. Like here 2 square. If I am supposing current is having a direction and magnitude, so that's why I am supposing current is a vector. So it means that current must follow. If the current is vector, then it should follow the law of vectors. Like if someone is human, he or she should follow the laws of human. Means someone suddenly is flying like Superman. So you cannot say that he is a human. So in this case, he or she is something else. Neither a human, okay? Means I want to say that here is 3 square. So this will be not equal to the 5. And in case of current, there are some, like here is a current of 5 ampere. So this current will divide like this, 3 ampere and 2 ampere. We will discuss this. But in case of vector, we cannot say. If a force of 5 Newton is like this, and here is 3 Newton of force, and here is 4 Newton of force. We cannot say this because we have to calculate the angle and all that. But in case of current, we can say. So basically, current is not a scalar quantity, not a vector quantity. Current is simply a tensor quantity. Please don't note it down. This is just for your understanding only. Okay. We will start out our main topic today is drift velocity. This is just I am telling you. So current is just the scalar quantity, not a scalar, not a vector, but current is a tensor quantity. Current have direction, current have magnitude, but current does not follow the laws of vectors. So there are some other quantity like tensor quantities which is not in your syllabus. Even this is not, this is in the syllabus of BTech first year, like stress, pressure. These are tensor quantities, but leave that. So you have to consider current as a scalar in your syllabus. If you say, if you have given the option, first option is scalar, second is vector. Suppose someone is asking uh, what is current. So someone, if first option is scalar, another is vector, third is uh, none of these. Okay, so you will take this option. From this will be more correct. But if someone added the tensor, so this will be more correct. TENSOR tensor. But this is not the part of your syllabus. So this is the reason that why the current is not following the vector law. We can see, we will see this will happen in the chapter. That the current will divide like this, but we cannot divide forces like this. So that's fine. So our next topic is this drift velocity. Actually, for studying the drift velocity, we should go inside the conductor. We will see what is inside the conductor, what is happening inside the conductor. This is our topic of today. Drift velocity. This is drift. Drift. This is velocity. Okay. Drift velocity. Write down the definition. Velocity of electron with which it moves, or sometimes you can say drift. Drift means like you can say drift is someone is moving like this. Uh, Suppose here is a person and there are some resistance in between the person and the person is moving here to here, it moves, now here it stops, and from here it moves like this, means running with some hindrance. Okay, so you can, that's why actually this man is moving, but we can say this man is drifting. So drift is something like this. So moves or drift towards positive end, E and the end of conductor under the action of electric field. So see here what happens. the conductor. We have to see the internal structure of conductor. I am telling what is inside the conductor. This is a conductor, I am saying. This is a conductor. You can say a part of conductor or a conductor. And initially, we know that inside the conductor, there are electrons, free electrons. We have not seen, I have not seen the electron, but scientists say that there are free electrons, and so, and there are ions. Have you seen the electron? No, no, I have not. I have also never seen the electron. So there are electrons. There are electrons and positive ions. These are positive ions. These are electrons. So in this way, electrons, positive ion, electron, positive ion. So okay, there is electron, there is positive ion, there is electron, there is positive ion, there is electron, there is positive ion, there is electron. Today, this is very deep topic in solid, like in material science. So we study in that the uh, what is inside the material. In that we are not going in that. This ion is positively charged and this ion is heavy as compared to electron. So for this ion, this is not free. Not free means this will not move. Okay. But this thing, this electron is free, can move. Can. This is just the a basic idea. This is just the basic idea. But in actual, when we see now, I am only focusing on electrons. There are ions also inside the conductor, but I am just focusing on electrons. What the electrons are doing? What the electrons are doing? Initially means when this conductor is not connected to the battery, like this is the condition when there is no teacher inside the class. Can you imagine? Like this. So here we know here are the electrons. Here is electron, but these electrons have some different story. These electrons have random motions. Random motions. Random motion means a motion of electrons. Okay, but the direction is very random. Like suppose this is the electron one going in this direction, another electron going in this, very random. So this electron is moving in this direction, 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 and this electron is moving in this direction. With some velocities, velocity is a vector quantity, so I am okay. Like this you can imagine. And this is the initial condition of electron. Electrons are moving in very random direction when there is no electric field applied to the conductor. And here I will say here U1, U2, U3, and I am supposing there are n number of electrons in this conductor. Are you getting my points or not?
Yes, I'm getting.
Actually, this topic is little bit you have to think. Okay. So these are the velocities of electron, but these velocities are due to the temperature. These velocities are due to the temperature. Like in this room, in this room, or you can say in your room in which you are sitting, there is certain temperature. Like you can say 28 degrees temperature. I am supposing. So you can imagine the air around yourself. There is a air around yourself, and air contains the elements, and element contains the electron. So the motion of that air, that electrons in air will be in random direction because of why the electrons is in the motion inside the conductor or in air. So now I am talking about the just inside the conductor. Why the electron have the velocity? Velocity comes from the Newton's law. Velocity comes when there is some force, or if the uh, actually this velocity is changing the direction also. So we will say there should be something that can give the velocity to electron, but that velocity is given by the temperature of surrounding. Temperature, we can see the effect of
Sir,
temperature. Yeah,
sir, this electrons move at different velocities or the same
yeah,
velocity?
actually these electrons, you can easily say that moves with different velocity, not with the same velocity. Okay, how can we say? Okay. So what I am telling, so these are the velocities of electrons. So we say these are thermal velocities. Thermal velocities of electrons. Have you seen the boiling of water?
Yes,
In
sir.
the boiling of water, what happens? It is the temperature. It is the temperature that increases the kinetic energy of the molecules of water. That's why they are moving like this in a random direction. So means due to the temperature, there is thermal energy. Due to the temperature difference, there is a thermal energy. Okay, that you can say heat, and due to that heat, okay, the electron moves like this. Okay. Now they are moving in random directions. Moving electrons initially move in random. I should write this also. Initially electrons moves in the random directions. And here from here you can see this. You have to get the idea only. Okay, if there is some vectors like this, like this, like this. So we can say for the easy calculation, we can say I can imagine this force this velocity can cancel out this velocity, and this velocity can cancel out this velocity. So this is just the idea. So from here, random direction due to this. Average thermal velocity of electron is 0. Velocity of electron is 0. Why the Emberly, the why we are considering the average thermal velocity of electron as 0? Why?
So because of vector addition, they cancel out each other. The force cancels out each other.
Means the velocities will cancel out each other. So if I want to calculate the average velocity, VAV means V average. I am writing. VAV means average velocity. If I want to calculate this, what is the meaning of average?
The velocities of all the electrons is added.
Yeah, and divided by the how many
Divided
velocities
by
are
the
there?
total number of this
Electrons.
electrons that are undergoing the.
Very good. Just wait for 2 minutes. Azan. Okay. Okay. So I am calculating the average velocity. There are n electrons. You can divide it by Write this as equation. Now I have connected this conductor with some power source, or you can say with battery. Okay. We have connected this conductor, the same conductor. This is the representation of cell or battery. This is the wire. This is the wire, and connected with some voltage. Now, initially, the electrons are moving in random direction. Now, when you apply the voltage, suddenly what happens inside the conductor? The electrons will move in a specific direction. This will happen. Like you can say this is a condition of a class after entering the teacher. All the students are at their proper places. So I will say the electrons, we have ions also. Electrons will move in some direction. And remember that electron is a negatively charged, so it will move towards the positive. And there are ions also in between. You can say here can ions, but now I am focusing on the electron. And electric field is generated, and we know that the direction of electric field is from positive to negative in the electrostatic. If you don't know, then I am telling you. Here is a positive charge. Here is a positive charge, and here is a test charge. Very small charge. Okay. Why the direction of electric field is like this? Here is the test charge. Very small charge. And the distance between these are two charges. Suppose this is a charge Q, and this is very small charge. We want to check the direction of electric field. So this is positive charge and this is positive charge. And we know the Coulomb's law. And due to Coulomb's law, they will repel. Repel means this charge will try to repel this charge in this direction on the line of action, in this direction. And this is the direction of force. And this is the direction of force. And the electric field is the force divided by test charge. And the you can say the direction of electric field is direction of force from this equation. So from due to the positive means that you can conclude many things from this. The direction of electric field is away from the positive charge, and if you take a negative charge here, and here is a test charge. Test charge is for testing the direction of electric field. Here is some distance. There is now what will happen on this charge? There is a force which is in this direction. Why? Because positive and negative will repel. So here the direction of electric field. What is the direction of electric field? Minus. You can say towards the negative charge. Means electric direction of electric field from positive to negative towards the negative charge means. So from this you can conclude that The direction of electric field is from positive to negative, positive terminal to negative, you can say. This is the direction of electric field. E is electric field here. E is electric field here. And now the electric field will, due to this electric field, actually. And you know that, I think you should know that, or if you don't know that, then I will tell you. Suppose here is a charge, Q charge, positive Q charge, and this is the electric field. Okay. So when you place a charge in an electric field, it will experience a force in the direction of electric field. It will experience a force, and the value of this force is the charge Q into P. I am talking about the magnitude. If a negative charge, you have placed a negative charge. In this case, what will happen? This charge will experience the force, but in the opposite direction of electric field. In the opposite direction of electric field. This is happening due to this. This is happening due to this. If you can relate this, then it's good. Okay. So I am just removing this. Should I remove this now?
Yes, sir.
Fine. So from here you can see that electric field is like this. Is like this. From positive to negative. Here the electric field is from positive to negative. Here is the electron. Electron is negatively charged. So the force will experience on the electron in this direction. Force. And this force is equal to charge on electron into electric field. Okay. Charge on electron into electric field. If I will convert this, yeah, okay. If I am writing this in the vector form, like force is a vector quantity, so I will take the sign electrons. The force and electric field are in opposite direction, so we will write this as equation 2. And this is a force on one electron, you can say. I am writing here force on each electron. Force on each electron. So this is the force on each electron. And electron have mass also. Electron have mass also. So I am writing here, if me is the mass of electron, Do you know about this? Okay, right.
Yes, sir.
So this is the result of Newton's second law of motion. Okay, this is the result of Newton's second law of motion. And from here, if I want to calculate the acceleration, then force upon mass, I can write in the vector form. You can write this like, okay. So if I want to calculate the acceleration of electron, I can write F upon mass of electron. Force is this. This is the acceleration. Now write down electron will collide with ions after one collision. It moves and after another collision will again. So what happens inside the conductor? There are electrons and there are ions. So now there is a force on the electrons. तो आप कल आ जाना फिर. ओके. तो 20 minutes. So Emberly.
Yes, sir. Yes, sir.
Okay, fine. So you can imagine now what is happening. You getting what are happening? These things are just, all things are happening inside the conductor. We cannot see. So here is a term is time. Electron will take some time for collision and all that. So okay. So here is a positive charge ion and here is a electron. This electron is moving in this direction and suppose this electron collides with this. Okay. Suppose this electron is collides with this, and after the collision, the electron will move from here. The electron can move in any direction from here. So you can say after the collision, suppose from here, this electron is moving in this direction. I will not take this direction because there is a force and force will try to move the electron in this direction. So from here the electron will move again. From here to here the electron will move away again. And after this the electron will again collide, okay, with the ion. There are ions also. So okay, have you understood now? So during this there is a time, there will be any time during this process, and this time is known as, this is tau. I am representing this as with tau, and this tau is known as the average time taken. Average time taken by electron between two successive collisions. So tau is basically time. Okay. Now now after the collision, after the two successive collisions, there is a change in the momentum of electron. If you know the momentum, so I will say there is a change in the velocity of electron. There will be a change if you don't know momentum. What is momentum? So I am saying that the velocity electron will definitely change. You can imagine this. If you will going and you will collide with some person, so your velocity will also change. Okay. So the velocity will change, and if I want to calculate the final velocity of electrons, of electron, final velocity of electrons. So we have this formula also. Final velocity is equal to initial velocity plus acceleration into time. We have this formula.
Yes, sir.
This is the formula from the 11th class. Final. And if for the one electron, if final velocity is v1 and initial velocity we know u1 due to the thermal condition, and there is the acceleration a, and for electron 1 I am saying that one electron taking a time tau 1, and these are, if I want to write this in the vector form, I can write. So for v1 I can write u1 okay, and we know what is value of a. You can see from here, this is a
Minus E, small e, capital E by M.
and I am taking it with sign. I am into tau 1. And similarly, you can write v2. For the second electron, the final velocity will be u2 plus a into tau 2. Sorry, this is tau 2. This is tau 2. So I can write u2 minus, acceleration is constant. Please remember this. So we can write for n number of electrons. For nth electron, this is mass of electron. So this is the expression for final velocity. Now I can take the average of these velocities also. V1, V2, V2, average of final velocities. So I am writing, actually I have done a mistake here. This is not V average, this is U average. Please modify this. This is U average because this is the initial velocity. U average. And this U average is 0. We have discussed here. 0. So I am writing this equal to 0. We have discussed that this is 0. Okay, so if I am calculating this average of final velocity, I am representing it with this. So I can write V1 plus V2 plus V3 plus Vn, and again this is divided by n, and this is the vector. So now I will put the value of V1, V2, V3 and all that. So I am putting the value of V1 is equal to U1. See here, Emily, see here. Now what I am doing, I am putting the value of V1 here, V2 here, okay? Into tau 1. This is V1. Similarly, you put the value of V2. Tau 2. And you can do this for n number of. And this is this part, and I am dividing it with n. Now this is U1 here. This is the addition, na? This is the addition. So you can write U1 plus U2 plus U3 like this. You can write now. So I am writing this. I am writing this U1 plus U2 plus U3 plus UN. I can write this minus. Now this term EEYME is common in all. EEME.
Yeah, it's
So
common.
from here, okay. So I am writing EE divided by ME. And now what will remain here? If this is common, I am writing this directly, otherwise it will take a large amount of time. So I can write tau 1 plus tau 2 plus tau 3. Okay. So I can write this as tau 1 plus tau 2 plus tau 3 and so on plus tau n. and this whole term is divided by n. This whole term is divided by n. So I can divide this by n, and I can divide this by n. Can I write like this? If you know
Yes.
little bit of mathematics, like I am telling,
Yes, sir.
like this is 50 and this is 5. What is the answer? 3.
3.
Now I am writing it with like 10 plus 5 divided by 5, and now I am writing it 10 divided by 5,
Plus
5
5.
divided by 5. So you can get the answer here
2
from 2
plus
and from
1.
this will equal. Mean this is a laws of this is mathematics. So I am using this simple mathematics of, I think, 7th or
Yes, sir.
8th
I
class.
got it.
And Emily, please tell me, what is this? What is this? We have seen this somewhere. This. This is this,
Yes, sir.
and this is equal to.
0.
Very good. So this is just U average, and here is E Y M E, and there is one term tau 1 plus tau 2 plus tau, and this is something known as relaxation time. This is known as relaxation time. So I am writing it with tau. We have already used tau, so I am not using here tau. Here I am taking the t. Tau is something different. This is t. I am taking this as t. Now here for this relaxation time, I am using tau. Tau is the average of time taken by electron. Average of t. This. Okay. So from here I can write this tau. This is tau now. I am supposing this tau. This is known as relaxation time. Okay. And this is equal to 0.
0.
So this is E tau by ME. And this is average velocity. And this average velocity is the drift velocity. So I can write for the drift velocity. For the magnitude, I can write the drift velocity as, if I am supposing V as a drift velocity. Okay. So I can write is E tau by mass of. So this is the expression for drift velocity. And from here you can say that in the definition we have written that the velocity of electron. So here it is better to write the average velocity of electron with which it moves toward the positive end of the conductor under the action of electricity. But that's fine, no problem. So this is the drift velocity. E tau by. And here is this is negative. This is negative. So from this negative sign we can conclude that direction of drift velocity of electron, drift velocity is opposite to electric field. Okay. And in the last class you have asked me one doubt, that why we take the direction of electric current from positive to negative. Actually, we do not take. Someone has taken earlier, that's why we are taking. So see here, what happened, why the direction of current is from positive to negative. This statement have many answers, so I am telling one. This is the motion of positive charge, and we take the direction of current in this direction. This is the direction of current also. But we have seen that this is defined earlier. This thing is defined earlier. There was a time when I think we do not know about the what is the motion of electron and all that. So someone said that the direction of current is the motion of positive charge. How he can say that the current is moving from positive to negative? Because positive is considered at higher potential and negative is considered a lower potential. So everything is moves from higher to lower. Like in case you can say water flows from high pressure to low pressure.
Yes.
Okay, this is for pressure, P is for pressure. How he has determined this, I am saying just I will take 5 or 6 minutes more. Now this was the earlier case. I am how he decided this. Pressure is from high, means the water flows from higher pressure to lower pressure. The direction of electric field is from higher potential to lower potential. In the direction of electric field, the potential decreases, and heat flows from high temperature to low temperature. And if a body want to be stable, so if a body is is want to be stable, then it will try to reduce the potential energy. Means if you will place a body here, and from here the body will move in this direction naturally. I am not saying forcefully. So means everything is trying to regain the stability. So they said that the direction of current is from positive to negative, and that's fine. But there is something known as electron. There is something known as electron, but electron behaves like this. If the electron is moving in this direction, the direction of current is like this, in this direction. So this is the conventional direction of current, and this is now the direction of, but all the calculation are done with respect to this. So that's why we take the, actually this is the best answer I can say. There can be the many answer on. So
Okay, sir.
okay, so that's all for today. You can leave, and if you have any doubt, please ask me.
No, sir, everything is clear.
What?
Sir, everything is clear.
Okay. So can I ask you something?
Yes.
Okay. Why the direction of electron initially, the motion of electron initially inside the conductor is in random directions?
Due to the temperature.
Yeah, due to the temperature. Very good. Okay, fine. Do you know what is acceleration? Actually, I have used this thing here. Acceleration is equal to force upon mass. This came from the Newton's second law of motion. We have three
Yeah.
laws of motion: first law, second law, third law. And acceleration I can write is equal to force by m. If we want to write in terms of a vector, so I have written this in terms of vector. So this is all about the drift velocity, and I think your answer, you will be satisfied with this answer. Okay. So now, thank you. You can leave this meeting.
Thank you, sir.